Hello everyone and welcome to another SQL tutorial with Learn at Knowstar. In today's tutorial, we are going to learn what is a recursive CTE and what are its different use cases. So let's get started. A recursive CTE, as the name suggests, is a CTE that references itself recursively or repeatedly and returns a set of data based on some logic. So it is kind of a loop and it keeps on referencing itself and returning subset of data, and it does that until it returns the complete set of data based on whatever criteria you have defined to stop the loop. So in the simplest form, this is how a recursive CTE looks like. It is similar to how a normal CTE would look like. The simplest example of a recursive CTE is to generate a sequence of numbers. So it's kind of a loop. Let's say you want to generate numbers from 1 to 10. So you declare some variable, you keep on incrementing the value of that variable by 1 till you reach 10. So this is what a recursive CTE will do. Now, how it actually executes and what are the components of a recursive CTE? Let us take a look. So the first part, as you can see, is a simple declaration of the recursive CTE, which is similar to a normal CTE. So you just need to use the with clause and give any name that you want to the CTE and then start defining the CTE. Now, when you define the CTE, there are two main parts to that CTE. First part is called the anchor query. Anchor query is the query that would fetch you the base results. So you said that you wanted to start counting from 1. So you need to define that 1 somewhere. That is your base, based on which you're going to increment the count. So the first part of the query is going to do just that. It is just going to select 1 in a variable called count. So select 1 as count. So what this is going to return to us is just the number 1. Now we come to the recursive part of the query. So the recursive part of the query is where it is going to reference itself. Now if you observe here, we defined the CTE as recursive CTE. So that is the name we gave to the CTE. Now in this recursive part of the CTE, we are referencing we are calling upon the same CTE. So here in the from clause, we are calling upon the same CTE, which is recursive CTE. But what are we doing? What logic are we performing? We are incrementing this counter value by 1. Now what counter is this acting on? This counter value is coming from the anchor query, which has set this counter to 1. So in the first iteration of this recursive query, we are going to increment the value of the original value of counter, which is 1 as set by the base query, plus 1. So what this is going to return to us is the value of 2. Now once it has reached the value of 2, it is going to check this termination check, which is your criteria in the where clause. It is going to check whether the counter value now is less than 10. So the counter value is 2, which is true. So this is true. So it is going to again perform the second iteration of this recursive query. In the second iteration of this recursive query, it is going to consider the previous value which was set for the count variable, which was 2, and then it is going to perform this logic. So 2 plus 1 is going to be 3, and then again it is going to check this condition until and unless this condition is not met or it becomes false. It is going to repeatedly call this part of the query, and this is how it is going to generate the sequence of numbers from 1 to 10. And then what we can do is simply run a select query on this CTE that we just defined, and just select star from recursive CTE, which is going to give us the desired result. So I'm just going to execute this query to show the results. So when you execute the query, you can see that you have got 10 rows over here. So if I just take it up a little bit, you can see that 10 numbers have been generated. So this is the simplest example of a recursive query and the simplest use case of a recursive query. Now there are other ways obviously in which this continuous series of numbers can be generated, but recursive CTE is one way in which you can do this. So one thing to note over here is, because since this is a recursive CTE, there's always a risk of the CTE entering an infinite loop. This could be because of a code error, or this could be because the data is such. So there's a hint which is set by default to 100 in this case by SQL Server. This hint is called max recursion, and this defines the maximum number of recursive cycles which will be executed by the recursive CTE, after which the code will come out of the loop. So if you observe in this case, if you try to generate a sequence from 1 to any number that is greater than 100, so let's say 150, you will be getting an error message. The error message will simply say that the statement terminated because the maximum recursion of 100 has been exhausted. So in cases like this, where you know that your coding is correct and your data is also such that you would need more loops to be executed, you can just define this hint with a value as per your requirement. So in this case, we are going to set it to 200, and then you can execute your query and you will get the results. The recursion, the max recursion, can also be set to 0, which would basically mean that there is no limit that will be imposed on the maximum number of recursive cycles. So you have to be careful with that. You have to make sure that it does not enter an infinite loop if you set it to 0 by hard coding the value of the hint of max recursion. Now let's move on to some other use cases of the recursive CTE. The second use case that we're going to consider is based on the similar logic that we use for numbers. Now there may be a requirement where instead of creating a continuous series of numbers, what you want to create is a continuous series of dates. So you have a start date and an end date, and you want to generate all the date for all the days which fall between these start and end dates. Now we have taken similar examples in many of our video tutorials that we have done earlier. So I will be providing some links to those video tutorials so you can go to those and explore in more details different use scenarios and how this recursive CTE logic can be extended to different scenarios. But for this tutorial, we are going to take a look at generating that simple series of date range as well. So let's do that now. So now I'm just going to copy this CTE that we have just defined, the simplest form of the CTE. I'm going to create a new query, and then I'm going to extend this to creating a date range. So for creating a date range, I'm going to define a start date and an end date. So to do that, I'm just going to use the declare variable, and I'm going to define the start date as a date column, and I'm going to give it a value, let's say 2022-01-01. And then I'm going to declare another variable which is going to be my end date. So end date, again date data type, and let's say I want to declare the date or create a date range till the 10th of January. So 2022 and 01 and 10. So now in this recursive CTE, I'm going to implement the logic for date. So instead of my base query returning 1 as the count, I'm going to have it return the start date as, and I'm going to call it something related to date. So let's call it, let's say, order date. And then I'm going to use a union all. So this we did not discuss earlier. Union all, you have to use a union all clause or a union clause to combine the results from your anchor query or the base results with the results of the recursive part of the query. So you need something to combine. You can also use except and intersect, but in most of the cases you will see that you will be using union all, because you at the end of it you want the complete set of results to be returned to you. Okay, so now I'm going to work on that. Select order date. So you cannot simply do a order date plus 1 for date because this is a date column. So you have to use the date functions. So the date function is date add in this case, and you're going to add a day. So I'm going to add a day to this column, and I'm going to add 1 day to this column. I'm going to make a recursive call to the same CTE, and then I just need to check this condition. So this condition, I am going to put this condition right here again, and I'm going to say is less than equal to at end date, which is the variable that I have defined over here. So now if I'm going to execute this query, let's just execute this query. What we are going to get is these 10 rows, and these are going to start from the 1st of January and they will go all the way down till the 10th of January. So this is how you can use the recursive CTE to generate a series of date ranges. Now, as I've mentioned earlier, we have done various tutorials. I will be providing a link below to all those tutorials so you can go and check them out for further extension to the logic of generating these different date ranges using the recursive CTE. So now we have done two different data types. We have generated a sequence of numbers. We have generated a sequence of dates. Maybe there's a scenario wherein you want to generate a sequence of alphabets. So you want to generate A to Z, A to E, whatever. Okay, so again, there are different ways. If you just need to generate a finite set of alphabets, you can actually go and just write it down, select A, union select B, and so on. But we will just see how we can do it and achieve it using the recursive CTE. So once again, I'm going to go to the basic example that we had taken. I'm just going to copy it. I'm going to open a new query window and I'm just going to convert this one to a simple sequence of alphabets starting from A going all the way till Z. So here, since we are counting alphabets, we have to use the ASCII value of the alphabets because that is what we can keep on incrementing, and that is a continuous series of number from, let's say, if you are considering A as a starting alphabet, the ASCII value is 65 and you can keep on incrementing till 90 to get the alphabets till Z. So instead of doing select one as count here, what I'm going to do is I'm going to do start counting from A. So I'm just going to do character of 65 as, let's say, alphabet. So that is going to give me A, that is going to form the base part of this query, and then I'm going to keep on incrementing the value of A. So to keep on incrementing the value of A, what I actually want to increment is this ASCII value, that is 65. So what we can do over here is just, since in the alphabet itself we have got the value of A as an alphabet, we want the value of the ASCII value here. So what I'm going to do is I'm going to increment, I'm going to convert back the alphabet over here to the ASCII value of alphabet. I'm going to increment a 1 to it, and then I'm going to take a cal of the whole calculation so that it will give me back the alphabet. So ASCII of alphabet is going to give me, in the first iteration, is going to give me 65. I'm going to add a 1 to it, which is going to give me 66, and then I'm going to convert it back to the alphabet using the cal function, which is going to give me the alphabet B. Okay, and I'm going to keep on checking this till my alphabet reaches a Z value. Okay, so I can say either is less than Z or it is not equal to Z. So this is how I can write this query. Now if I'm going to execute this query, let me see. Okay, we have got 26 rows and you can see we have got a continuous series of alphabets from A, B, C, D, E, F, G till Z. Okay, so this is how you can use this recursive CTE concept to generate a list of alphabets as well. Now, if you want to generate them in small case, you can start from 97, I think. Okay, and again, because SQL in itself is not case sensitive, so you will get them in small alphabets and they will go all the way till Z. So this is how you can use this use case to generate a series of alphabets. Now let's take a further extension of this and complicate it a little bit by going back. Let's go back to the one wherein we generated the numbers. So this is the one that we started with and we generated numbers. So now I'm going to extend this concept and I'm going to consider a string and I'm going to derive the position of each alphabet in that string, and then I'm going to split it into different rows. So what I'm trying to do over here is, let's first write a query. I'm going to find the position of each alphabet in that string. So to do that, let me just declare a string called add variable, and this will be, let's say, varchar 100, and the value we can give as Knowstar. So this is my variable, and I'm going to split each alphabet, so K, N, O, W, and put them in separate rows. So what I can do here is, first I can generate the number of positions. So the total number of positions will be equal to the length of the string. So in this, you can see there are 8 alphabets here. There are 8 alphabets, so I need to generate 8 positions. So what I need to change in my CTE over here is, I can start with 1 as count, select count as 1, so recursive part will also be true. The only thing I need to change is this termination check. So I want to keep on counting till I go to the length of this variable that I just declared. Okay, so this is what I want to do. So let me just execute it, and you will see that we have got 8 positions generated. Okay, so I have got the 8 positions which correspond to the 8 alphabets and this string. Now the second part here is, I'm just going to add some logic, and I'm going to extract the substring with each recursive iteration of the CTE. So what I'm going to do is, I'm going to use the substring function over here. So the first argument that we need to pass to the substring function is the variable. So our variable we have declared in this @var, and then from which position you want to extract. So the position that I want to start extracting is the value that I'm getting in the count variable. So let me just put count over here, and then how many characters you want to extract, just one at a time. So that is what I want to do. So this becomes my CTE. Now what this is going to do is, with each iteration, it is going to start with the value of count is going to keep on changing. In the first iteration, it is going to extract the string, the alphabet at the first position of my string, which is going to be K, then at the second position of the string, which is going to be N, and so on. So now if I execute this, this is the result that I am going to get. So this is just to give you an idea how the concept of recursive CTE can be extended in various situations. So this is a very useful concept because it kind of provides you a way to generate a logic within a loop, and therefore there are many use cases that can happen that can be used with the recursive. So these are one kind of use cases where you kind of generate a sequence. The other very important kind of use case for the recursive CTE is to query hierarchical data. So when we say hierarchical data, we are talking about an employee manager hierarchy, a family tree hierarchy, something of that sort. So employee manager hierarchy, there can be a manager. Within the manager, there can be 10 employees. Out of those 10 employees, there can be sub managers under whom there can be more sub employees, and so on. So it is like you have a grandparent, then you have 2 parents, then those parents have children, and so on. So this is a multi-level hierarchy that we are talking about, which can be addressed with a recursive CTE. So the most popular example obviously is the employee manager hierarchy. We have already done a video on that, so I'm just going to provide a link to that because it is explained in a very detailed fashion in that video tutorial. So you just click on that link and go through that, because that is a very major use case of the recursive CTE. Another major use case based on the same hierarchical principle is the bill of materials. So that is what we are going to do in this particular tutorial, because we have not covered it separately in any other tutorials on our YouTube channel. So that is what I'm going to cover. It's very similar to the employee manager hierarchy or the family tree hierarchy. So you will get an understanding of what is happening, but still I would suggest that you go and check out the employee manager hierarchy tutorial as well, because that is what, like, if you are mainly interested in an interview scenario, then that is the question that would most probably be asked. So let's start with our bill of material hierarchy. So for this part of the use case, we are going to be working with a table called the part list. Now this is a table that is given as part of the IBM documentation for the recursive query. So I will also be providing a link to that documentation. It has various examples which are also very useful, so you can check them out as well. Also, I will be providing the link in the description box to the create queries and insert query for this particular table. So you can go ahead and create and insert data in this table, and then you can work with writing the recursive query. Now, to understand the structure of this table, we have simply 3 columns in this table, which is part, subpart, and quantity. Now we are saying bill of materials. Bill of materials is basically it is used when there is a one part or one component that is made up of multiple subcomponents, which in turn can be made up of other set of subcomponents and so on. So you have kind of a hierarchy here. So there is a part A, which is made up of two components, 1 and 2. Now 1 in turn is made up of three more components, X, Y, and Z, and so on. So you have a hierarchy. So your part A is made up of 1, which is also made of X, Y, and Z at a lower level. So to understand this particular kind of hierarchical relation and to calculate the quantities, the total quantities of components involved and so on, that is where you need to use the recursive CTE to understand this bill of material structure. So for our case, we are just going to understand this hierarchy and at which level of hierarchy are these different components related. So here in my example, I have just a few records. I have the part which is, let's say the first part is 0, 0. As you can see, it is made up of two subparts, 0, 1 and 0, 5, and you have the quantities related to those many subparts. Now if you go to 0, 1, you will see that 0, 1 has got different subparts, 0, 2, 3, 4, 6, and so on. So if you go to 0, 2, 0, 2 has another subpart called 0, 5, and so on. So there are different levels of hierarchy. So we'll write the query and then you will be able to understand this better. So let's start with defining the recursive CTE. So let's just call it with part list underscore CTE as and so now we need to define the base query or the anchor query. The anchor query is going to give you the results of the topmost level. So in this case, the level at the top, you can just define the level. You can define part 0, 0 as a topmost level because that is your product at the highest level, and then it is split into different subcomponents. If it is employee manager hierarchy, then you can go for, you might have null values in the topmost manager. The manager ID for the topmost manager would be null because there is no other manager on top of him, so you can use that. For our scenario, for the bill of material, we are going to just define it, hard code it to 0, 0. So what I'm going to do is I'm going to write a base query, select. Okay, so I'm just going to define, let's just select part and let's select subpart and quantity, everything from this table. And then I'm going to define a level, based on which level you are going to see what is the level of the hierarchical relationship. So I'm just going to define a base value as 1 as level from our table, which is part list, where part is equal to 0, 0. So what I'm going to get as a result of this query is basically these two records. Okay, so now I'm going to write the recursive part of this query, and I'm going to just use the union all to combine the result with this base part of the query. So in the recursive part, we have to fetch the child records which are related to the records which are resulting by this anchor query. So I'm just going to copy this and the level, I'm just going to increase the level by 1 for the child record. So the topmost level is going to be 1, then the immediate child record, the level will be 2, and so on. And then we have to use the same concept of self join over here because we are finding a relationship. Whenever you are finding a relationship, so you are joining between two instances of the same table, because the relationship here is when I find the subpart in the part column, that becomes a relationship here. So this subpart now becomes a part which has its own subparts. So this is the kind of relationship which is same as what we do for the employee manager relationship as well. So now what I'm going to do, which is my parent table? My parent table is this particular anchor query which I have just written. So this CTE that I'm going to reference becomes my parent table. So part list underscore CTE. Let's just call it parent to make it easier to understand. And I'm going to perform an inner join on the child records. The child records I'm going to fetch from the original table, which is this part list table, which is the physical table that exists. So partless, I'm just going to call it child. And how do you define the relationship now from the parent table? So whatever results came up, because they are at the topmost level, so those are the parent records. So parent dot whatever comes in the subpart column over here is going to be in the child table, in the child instance of the table. It is going to be equal to what is in the part column. And since we have defined it in a join, you need to qualify the name here. So child.part, child.subpart, and child.quantity. And this is what will define your query. And what we are going to do is now just do a select star from partless underscore CTE to see what are the results. So if I just execute this now, what we are going to see are the different levels. So you can see at level 1 is your part 0, which has two subparts 0, 1 and 0, 5. At level 2 over here till here, you can see are those two subparts now become level 2, it is 0, 5 and 0, 1, and you can see the subparts that comprise those level 2 parts, and then you go back to level 3. So you drill down another level of hierarchy and you get the subparts of 0, 1 and 0, 5. So based on this level, you will be able to understand at what level of hierarchy those components or those records are residing. So this is how you can generate this relationship. So I hope that you found this video useful. We are going to be covering more videos on SQL concepts and also covering different scenarios of SQL queries. So please do not forget to subscribe to our YouTube channel. And if you like this video, then please do not forget to like, comment, and share this video. Thanks a lot for watching. Bye.